later. So this is the third part of this big data reverse. And the topic of this third part is tools of big data. That is what specific tools really help us out with respect to this big data. So let us see the types of tools that's usually used in big data. Let us try to understand where the processing usually is hosted. So it will be distributed servers on cloud. For instance, we can take Amazon EC2, and where data usually gets stored. So it's like a just the distributed storage. So, as an example, we can say like Amazon S3. What about the programming model? It can be distributed processing, for example, MapReduce. So how the data is stored and indexed? High performance schema-free databases. I'll just how to mention this. Example, MongoDB. And what are the operations that are performed on data? It is either analytic or semantic processing. So with that said, let us begin with what are all the different types of tools that's used in big data. HDFS was the original game changer, allowing companies to store petabytes of data affordably. Today, NoSQL databases provide the flexibility needed for modern applications, and cloud storage like Amazon S3 just become the default for the scalability and ease of use. So this is where the magic happens. While MapReduce pioneered distributed processing, Spark completely revolutionized it with its speed and versatility. Most new big data projects are built on Spark. So with that said, let us try to understand what is this Hadoop. So Hadoop is an open source framework for storing and processing big data. It provides a distributed file system called Hadoop Distributed File System, which is HDFS, and a computational framework called MapReduce. Hadoop Distributed File System is designed to store and manage large amounts of data across a cluster of commodity hubs. So we understood what is Hadoop, normal framework processing big data. Hadoop Distributed File System, the purpose behind it. Now let us move on to the next tool, which is Spark. Spark again is an open source data processing engine for big data analytics. It provides an in-memory computational engine processing large data sets. So we can say 100 times faster than the Hadoop's MapReduce. Spark's programming model is based on resilient distributed data sets where distributed data collections can be processed in parallel. Spark supports various programming languages So what are they? You can say Python, Java, then you can make it easier for the developers to write big data applications. So Spark really helps them out in achieving those aspects. The next tool, NoSQL databases. So can be MongoDB or Cassandra. So an open source NoSQL database for handling big data. So it was initially developed at Facebook and was later open source. Cassandra is designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. It is just a peer-to-peer architecture which allows it to scale horizontally and easily handle increasing amounts of data and traffic. MongoDB is a big data tool. It's mostly compatible for users who work with data that changes often, such as sales or engagement information and unstructured data. MongoDB can store large amounts of data from various applications, product catalogs, and various other data platforms. So we have seen about MySQL, which is an open source MySQL database for handling data. We have Facebook and open source. So I got an idea about what is Cassandra. Let's move on to the other tool, which is Hive. Hive is an open source data warehousing tool for managing big data. It manages large data sets stored in Hadoop's SDFS or other compatible SQL-like queries called HiveQL. HiveQL is similar to SQL, making it easier for SQL users to work with Hadoop. Hive translates HiveQL queries into map-reduced jobs, which are executed in a faster mode. So that is about the Hive and open source data warehousing tool for managing the data. So Pig is an open source platform for data analysis and manipulation of data. Pig being another tool is again an open source platform for data analysis and manipulation of data. So it was created to make it easier for developers to process and analyze large amounts of data. Pig provides a simple scripting language called Pig Latin, allowing developers to write complex data processing tasks concisely and easily. Pig translates Pig Latin scripts into a series of map-reduced jobs that can be executed on Hadoop cluster, allowing it to scale to handle substantial amounts of data. This makes Pig well suited for use in big data processing and analysis. So once the data is processed, we proceed towards extracting the value. In, it is to be understood that Hive opens up big data to a wide audience of SQL analysts, more advanced work, data scientists use Spark's MLive for large-scale modeling or Python and R with their rich ecosystems for data analysis. All the processing in the world is useless if you can't communicate the results. So we will see tools like Tableau and Power BI, which empowers the business users to explore data visually and make informed decisions without needing to write the code. So this is just to have an idea about these tools really complementing the huge amount of data that we have. Another tool is HBase, which is an open source NoSQL database for handling big data, especially unstructured data. If you remember the previous sessions, we did discuss about what are all the different types of data, that is the structure of the big data. It can be either in proper structured manner with rows and columns, or it can be unstructured data. It can also be semi-structured. So this HBase is an open source university database that we work with unstructured data. So it is a column-oriented database that provides real-time random access. HBase is designed to handle huge amounts of data, scaling to billions of content columns. So it uses a distributed architecture, allowing it to scale horizontally across so much of servers and provide high availability with no single point of failure. That is the key aspect. So we are not talking about something huge is being handled, but end of the day, it's about the availability we are talking about. It is very important. So we need to maintain that no single point of failure. So the big data ecosystem is a pipeline of specialized tools, each solving a specific problem from ingestion to visualization. The landscape has evolved from the foundational Hadoop or MapReduce to the faster, more versatile Spark. Cloud platforms, to name a few, Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So these platforms have become the dominant way of building and deploy your data solutions, offering managed scalable services. Choosing the right tools depends entirely on your specific use case, budget, and the team expertise. Another tool is R, which is a big data analytic tool that is most common in the fields of statistics and data mining. But it can be helpful for those running large amounts of data from different sources. The R software is an open source program that's free for public use, making it popular for those searching for affordable big data tools. A key distinction of the R system is its advanced interface and graphics and its charting features that allow users to visualize their data. So the next tool is Tableau. The Tableau program is a big data analytics tool that offers customers widespread integration, making it desirable for users interested in running multiple data tools at once. So we're not talking about one at a time, so we're talking about multiple data tools at the same time. This tool offers users the ability to manage data regardless of the size and industry reputation for the user tool. Tableau also offers real-time processing and organizes data in a customized manner. So however you want it, you'll be able to project the data to try to understand the patterns. So the hidden patterns, these tools can really help you out to understand what exactly is the pattern so that it can be understood and accordingly the market can be worked for and the target audience can be satisfied and the appropriate revenue can be generated by the organization with such tools. So other type of tools we'll just try to see some brief detailing. So Patch Kafka, distributed streaming platform, the industry standard for high throughput, real-time data feeds, example, website clicks, logs, IoT sensor data. So Apache Flink is another tool, which is a powerful stream processing framework known for its low latency and high accuracy in real-time applications. Another tool is Microsoft Power BI, which is BA stands for Business Intelligence. With this Microsoft Power BI tightly integrated the Microsoft ecosystem like Microsoft Azure, Microsoft Office 365, known for its powerful features and accessibility. Another tool is Apache Superset, which is an open source modern data exploration and visualization platform. Then we have Looker, which is with respect to the Google Cloud, a Power BI platform that focuses on creating uh, reliable government data for organizations. So with all these tools understood, so that is starting from NoSQL databases, Kafka, Power BI, all these tools, it's pretty hard to identify the right tools because you cannot say one size fits all solution. So you need to understand the different types of data, how exactly you want them processed, what will be the scalability requirements, that is, much to what extent are you utilizing it now, and in the future, will there be additional needs? How are you going to manage them? And what will be the cost behind it, and also the team skills, then finally the integration. So let us see one by one how exactly you work on it. So the type of data, is it structured, unstructured, or streaming data? It is SQL database or color. Next is the processing needs. Is it batch processing or real time? So, for example, you can say, where is it like rapid use of Spark Stream? Then the other factor is scale. How much data are you spending now, and what is that can be expected for the near future? So cloud solutions are great for this, wherein you can try and predict and equip accordingly for the future. First, what is your budget? Open source versus managed commercial services. You can try and identify what will be the amount of money that will be in order to keep that things in place. And team skills, what technology does your team already know and how exactly you equip them for the upcoming needs. Ecosystem integration, how well does the tool fit with your existing. It is extremely vital because you do not want to stop something that's already going well. So how exactly is this new tool trying to fit it into that? So it is important that you take all of these things that is starting from the type of data, what processing will you be doing, and the needs currently, what will be the need in future, cost, the team who will be working with this, and how exactly you get this all integrated into the system. So you understood what are all the different types of tools this big data, and we have seen those types also in a big way, like Kafka, and NoSQL, Power BI. So all these tools have different abilities. Let us try to understand if you got this topic right. So here there is the MCQ. So two questions are there. Let us take 3 minutes of time. We will start discussing the answers. So time starts now. Proceed. 2 minutes is finished. Still have another 1 more minute. After that, we'll start discussing the answers. together. So let's start the discussion. So the first question, which tool is an open source NoSQL database designed for handling unstructured big data? The question is, which tool is an open source NoSQL database struggling handling unstructured big data? Okay. So the right answer for this is text-based. Okay. So we are talking about open source NoSQL database for handling unstructured data. If you had listened to this from the first, you would have seen what the significance of text-based. So it cannot be high, big, or spark. It's they're not the NoSQL database for handling unstructured data. Okay. Let us move on to the next question, which is where is big data typically stored in a distributed computing environment? So the options are where is big data typically stored in a distributed environment, local hard drives, distributed storage, which is Amazon S3, or centralized SQL databases. The last option is RAM only, random access memory. So where do we have this big data being stored, distributed computing environment? So the right option is distributed storage, Amazon S3. So you can see the right answer for the first one is H-base, and the second one is distributed storage, Amazon S3, the big data, the distributed computing. So if you want to gain more knowledge on these tools, how exactly do they work, the working principle behind it, and all these are mostly open source. So you have to just learn to work with it and utilize different data sets and see how these tools are working all over the data, which is and the references of this content you can see the data analytics textbook published by Wiley in 2015. Then there is also top 20 big data tools used by professionals in the recent times for the past 3 4 years. So it's available in this portal analytics.com. This is something that's being used by the industry professionals in the past 2 3 years. So for additional information on these topics about the different types of tools, you can go ahead and refer this textbook and then the website for which is analytics.com slash blog. With that, we come to the end of this particular tools of big data session. So in that we have started to see about the different tools, how exactly they help us out. Let's NoSQL database, Apache, Kafka, how exactly are they complementing each other. In this big data utilized and processed, and also to have proper visualization to understand what is the pattern of it. So many organizations are using it effectively. Thank you for your patience in listening to this session. So the upcoming topics will be first this week. Thank you.